Hi Math 1 students. Today we're going to talk about task 7.3. Can you get there from here? And what it is about is using a sequence of transformations to get from a pre-image to an image. We can always use a sequence of transformations to get from one place to another with congruent shapes. So we'll talk about all of those details as we progress through here. We have two quadrilaterals shown here, quadrilateral ABCD and quadrilateral QRST. The name of these quadrilaterals, ABCD and QRST, are made up of the vertex names, or the vertex labels, and angle A, B, C, and D are labeled as such on this quadrilateral, and QRST are labeled as such on this one. Now, these are two congruent quadrilaterals. It says they are congruent, with corresponding parts marked on the diagrams. Hopefully you remember how to mark corresponding parts on polygons or quadrilaterals. Basically, we use, for matching angle measures, we use matching arc symbols. So if you look at angle A, you have one arc drawn. On angle Q, you have one arc drawn. That means that those two angles are congruent and they are corresponding. If you notice the name of the quadrilaterals that was given, the first angle listed was angle A for the first one, and angle Q for the second one. Those first letters are in the same position in the names because they are corresponding angles and they are congruent. Likewise, let's look at D and T. Angle D is on the bottom left down here on the first quadrilateral. Angle T is also on the bottom left here, but they are marked the same. Look at these markings. You have an arc with a tick mark in the middle, an arc and a tick mark in the middle. That means same markings. That means those two angles are corresponding angles and they are congruent. In the names of the quadrilaterals, those letters are in the exact same position, the last letter in each of the names. You could do the same thing with angles B and R and angles C and S. And confirm that by looking at the markings on the picture. If you need more help or a refresher on how to mark corresponding parts of congruent figures, I have a video that I linked, provided the link for in the Canvas page. It's just a YouTube video. I just searched it and found it, so it's not the greatest video of all time, but it'll show you how to name those corresponding parts. So you may find it useful. Now if I could get back to my, here we go. All right. Our task for today is to describe a sequence of rigid motion transformations that carry quadrilateral ABCD on the left onto quadrilateral QRST on the right. And when we say carry onto, that means that this quadrilateral has to match up exactly with that one. So we need transformations, and we need a specific sequence of transformations to make that happen. You want to be able to describe these so that someone else can perform the same series of transformations and make that happen. Basically what we're doing with these transformations is we're kind of proving that these parts are congruent. The parts that are marked are congruent. Kind of like with the tessellation, we created tessellations with some transformations involved with their creation, and then the repeated use of the tessellation of that shape over and over kind of illustrates the congruency there. What I have is this. I made a little puzzle piece to go there to represent that quadrilateral. Basically, we have to translate, which is move in the X and Y direction. We can rotate, and we can reflect. And remember, reflection would actually flip this whole thing over. Okay? We need a sequence that'll make that happen. And in any of the rigid motion transformations, if you remember what rigid motion means, it means that your shape maintains the same size and shape. So congruency of the shape will be maintained throughout this process. Okay, so our task is to figure out how we can move this piece and translate it, rotate it, reflect it in some way to make it look like this. Now, if you just turn this around, say all I did was rotate it and translate it over, it doesn't really match. So there's definitely going to have to be a reflection involved. I need to flip this piece over. In fact, if I do flip it over, this is what I'm trying to do here. If I flip it over, I can get it to work. So this is, let's say this is side 2, and the other unflipped or unreflected is side 1, and that doesn't match. So that is our task. What are we going to do? Actually, before we do that, I would like to identify all the corresponding parts that we have here. And I'm going to put that on the right here. Based on the markings that are here, corresponding angles, and they're also congruent, and corresponding sides. So let's mark that. So let's start with, we can actually just use the language that's up in here, but we'll confirm it with the markings on the picture. Angle A is congruent to angle Q. A and Q, they have one arc. Angle B is congruent to, so if I look at the arcs, I've got 2 arcs here. The place I have 2 arcs here is angle R. So B and R are congruent and corresponding. We could also see that because it's the second letter in the name. And then what's the third one? Angle C and angle S. Angle C is congruent to angle S. And then the last one, angle D, is congruent to angle T. Okay, so we have corresponding angles on these 2 congruent shapes. How about the corresponding sides? Corresponding sides, you can also just use the name to find all your corresponding sides. Think about it. If I look at segment AB and segment QR, the letters are in the same position in the name, and they're going to be also congruent parts on the figure. So I'm going to go ahead and write this one. Segment AB is congruent to segment QR, and we'll confirm it on the figure. Segment AB, that's this segment here, it's got 1 tick mark. It's congruent to segment QR. QR is right here, it's got 1 tick mark. Also, it's the segment in between the angles with a single arc and a double arc. This is the segment in between the angle with a single mark and a double mark. That's another way you can see that they're congruent. Alright, the other corresponding sides, I'm just going to go around here. I'm going to do segment BC next. So BC goes from double arc to triple arc. So for this, it's going to go from double arc to triple arc, RS. I could confirm that in the title. I mean in the names of the quadrilaterals, BC, RS. So actually you don't even need the pictures to do this, but I'd like for you to be able to do it either way. Third step, I'm going to go CD, segment CD, congruent to segment, so that's the 3 to the 1 with the tick mark, 3 to the 1 with the tick mark, ST. And then the final one, DA, segment DA is congruent to segment TQ. So actually in our naming, if you just use the name of the quadrilaterals to do that, you would have to go DA, so last place to first place, is congruent to TQ, last position to first position. Alright, there's corresponding angles and corresponding sides. After we do rigid motion transformations to get from here to here, the markings on this original quadrilateral will pair up with these markings, with these congruent pieces that we've identified. Okay, so that's the setup. So let's get moving on the actual rigid motion transformations. Now I need to translate. Remember, that's just a X and Y direction. I need to rotate, and then I need to flip or to reflect. So actually the easiest way to do that, if we think about, I would like for you to think about how you might do it, and if you want, you can pause the video to try to come up with a method. But if you think about it, on all the practice that we've done, when we're rotating around a particular point, say point Q or something, that always makes the rotation a little bit easier. So if we take our first step to just translate and get one pair of angles matching up on their point, that is a great first step. Then I can rotate around this point A or point Q. If I rotate, and you know what, it doesn't even matter how many degrees this is, I want to rotate until I get this in a position to where I have a side matching, just like that. Segment AB and segment QR are lined up, and they are congruent. My final step would be now to just flip this over. And I need a line of reflection, but how about this? What about just this line that makes up segment QR for segment AB? Flip it over that line. And if I flip it over that line or that segment, it will land right on top of my second quadrilateral. And I can see that everything matches up. My congruent angles match up. My congruent sides, although I don't have those marked, all match up. We can see visually that the first quadrilateral fits right on top of the second one. Now we just need to document that. So what did we do? I'm going to pause the video a few times and take some steps to write out what I'm doing. So you can pause the video so you can catch up with the notes. But the first thing we need to do is, we talked about translating. So we want to translate, I want to match up A to Q, because I know that those are congruent angles, and I want to match those up. So how do I translate point A to coincide with point Q? Coincide means they're going to land right on top of each other. How far do I have to move? So if I count off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units in the X direction, and then up 2 units in the Y direction, that is a translation. That'll put me right there. Remember, nothing else rotates or moves. My translation rule is X plus 10, Y plus 2, and that puts me right there. I'm going to actually sketch that location as an intermediate step. This is like magic. So what did we do? We translated, and my new position is sitting right there. Now, ultimately, I'm trying to get to there. So my next step that I have to do, I'm going to rotate around this point Q. So I'm going to leave A and Q touching, and I'm going to rotate, in this case, clockwise. I don't know how many degrees. I don't really care how many degrees. I'm going to rotate until segment AB and segment QR touch, until they coincide. All right? Let me document in the notes what we just did there. Okay, we're going to rotate about point Q clockwise until segment AB coincides with segment QR. We're going to rotate just like that until those segments coincide. Now, could we go the other direction? Sure, we could, and let these sides line up. You're going to get the same result, so either way will work. Our third step, our final step, is a reflection. The line of reflection is segment QR, the line that contains segment QR. And basically we're going to take this and we're going to reflect it right over like that, and then we'll be done. I'm going to write out those notes next. So I have finished my notes, and I have shown this reflection. Reflect across QR. You could also label it AB, but really it's QR, to carry quadrilateral ABCD onto quadrilateral QRST. We basically, via transformations, have proven that these two quadrilaterals are congruent. Good luck on your homework.